Now we proceed to revision 3, which is on complex functions. We are done with complex numbers. Now let's have a look at complex functions. Okay. We have a question. Consider a complex function f of z equals to sine z. Decompose f of z into its real and imaginary parts. So the first thing, let's define z. Z is x r plus I y. That's the first thing. Now, let's substitute z. So f of z will be equals to sine into bracket x plus iy. Now, we have a property of trigonometry that says, so applying the property of trigonometric that says sine A plus B equals to sine A cos B plus cos A sine B. Have I got it right? Now, if you recall that, we can now express our sine x. That means sine x plus iy, applying the property, will be sine x and then cos iy plus cos x, then sine iy. Now, taking a note, you should note that our x is our A and our y is our B. Iy is our B. Now we are good to go. So we also know that cos iy is the same as hyperbolic cos of y. We can prove that, but not now because we were not asked to do that. And also we know sine iy is I hyperbolic sine of y. Now, having done that, this is what we have now. Now, our f, okay. Now, our f of z will be equals to sine x hyperbolic cosine of y, then plus I cos x hyperbolic sine y. So from this, your u, which is your real part of the complex number, is sine x cos y, so hyperbolic cos. So sine x cos y. Now your complex part, which is v, y, is just cos x hyperbolic sine y. So that is how we expressed or we decomposed our function f of z equals to sine z into real and imaginary part. So the real part is u and the imaginary part is v. Hope that is nice. And this one can be proved. Only that it is not now. We'll do maybe later in another example. So we moved on. And that was 4 marks. I hope this is also 4 marks. Okay, so we have another question. F of x equals to z squared plus 2. Can now just say I to z. Now, we know that z equals to x plus iy. So the first thing, we are going to get z square, which means x plus iy squared. And this is very easy. You square the first term the normal way we do. We will follow the standard way of expanding a plus b. So a plus b squared is simply a squared plus 2ab plus b squared, standard way. Now it means our z square is simply a squared is our x squared plus 2, of course, I 2xy, then plus our y squared negative 1. Why? Because b is iy. I squared is negative 1, y squared is y squared. Now this will be simplified as x squared minus y squared for the real part, then plus I 2xy, which is the imaginary part. Now again, that is for z square. We also need to express 2z. I to z will be I 2 into z, which is x plus iy. Now expand. I2 times x will be I 2x, then plus I times I is negative 1, then 2 times y will be 2y. So this is simply 2 negative 2y, which is the real part, plus I 2x, which is the imaginary part. Now we can proceed. Our function f of z will be our z square, which is x squared minus y squared for the imaginary part, then plus I 2xy plus our iz 2z, which is I 2x minus 2y. Is it 2y? Yes, minus 2y. Correct. Now collecting the real part together, we'll have x squared minus y squared minus 2y. This is the real part, plus the imaginary part. We have I 2x, I 2xy plus 2x. It's the way you want to factorize it. So your u xy your u, let me use blue, your u xy equals to the real part, x squared minus y squared minus 2y. And then your imaginary part, vxy equals to 2x, which is common, into y plus 1. Depends on how you want to give your answer. But whichever you have will be correct, whether you factorize it or not. Okay, we moved on to number C. So number C says f of z equals to e power z. But we know that z equals to x plus iy. So it means we are going to have e power x plus iy. I've just replaced z. Now I want to work on this. Now e power x plus iy, we are applying the index law when you are adding, can be e power x dot e power iy. I hope you recall that e power n dot e power m is the same as e power n plus m. Index law, sum. So the product, when you are multiplying with the same base, you add the power. So we have x plus iy is the same as e power x dot e power iy. That's your first step. Now again, we know that, we also know a rule on exponential form that ei theta is the same as sine, not sine but cos. Euler's formula is the same as, why am I keep on writing sine? Cos first, the real part is cos theta plus I sine theta. So it means our e iy is the same as cos y plus I sine y. Now bring in our function. So f of z is equals to our e power x times our e power iy, which is the same as cos y plus I sine y plus I sine y. And that has proved what we were told to do. E power x into cos y plus I sine y. Okay, this one also had marks, and that is 3 marks. Okay, that's it for C. Now we go to D. So f of z is given to be 1 over z. So we substitute so that we get 1 over z, which is r into cos theta plus I sine theta. We are given z to be that. Now let's work on 1 over r cos theta plus I sine theta. Now, to work out this, we multiply both the numerator and the denominator by a complex conjugate. So cos theta plus I sine theta, the conjugate is simply the negative here. So cos theta minus I sine theta. You do on top as well. Cos theta minus I sine theta. We call that complex conjugate. When you do that work, you are going to get 1 times everything, give you cos theta plus I sine, not plus but minus, cos theta conjugate, minus I sine theta, close the bracket, all divided by, you remember when we are getting a complex conjugate, I will write that for you, just to remember, that z dot z that, which means z times its conjugate, is the same as x plus iy times its conjugate, which is x minus iy. The result is always x squared plus y squared. It becomes a real number. Now, the same thing we can apply. Cos theta plus I sin theta will be cos squared theta plus sine squared theta. I think you are seeing directly here that our x is cos theta and our I and our y is sine theta. I hope that is it. Or if you like, IY is sine theta. Is I sine theta. So that's good. Now, we bring back our things, but before then, we need another thing, trigonometry. We know that cos squared theta plus sine squared theta is equals to 1. Now it means our f of z is equals to cos into bracket theta minus I sine theta all divided by r, because r cos this is just 1, so r times 1. Now we separate the real part and the complex part. So the real part will be cos theta over r minus the complex part will be I sine theta over r. So that is it. And that is what we have. U r theta, you can see u is this part. So this is our u as a function of r and theta, you can see. And then this is our v as a function of r and theta. You can separate to list u and r, but you're asked to leave it in that form. So we already have that. Now that marks the end of revision 3 and a complex decomposition.